Alright, so this question is for one of my AP students. She had a look at this integration example and she's unsure as to what's happening with the power. So let's work through this example. Okay, so I'm going to rewrite it, but instead of saying x over 2, I'm going to say half x. So I'm working out the integral of 1 plus half x, and we don't like the root sign whenever we're integrating or differentiating, so that's the same as putting it to the power of a half. Don't forget the dx. Alright, so when we integrate, we always want to try and do it by inspection. Doing it by inspection means I need to see a composite function multiplied by the derivative of the inner function. So what I want to do here is I want to see a composite function. There it is, a function inside a function. But I also need to see the derivative of the inner function. So the derivative of 1 plus a half x is a half. So I can just put that there. That's what's so cool about integration. So I'm going to put that a half that I want. I'm going to just pop it in there and write everything else out. Half x to the power of half. But because I introduced half, I need to compensate for that. So I need to times by 2, because then in essence I've got 2 times a half, which is 1. So that's where that a half comes from. Now what I have here is I have my composite function over there, and I have the derivative of my inner function there. And what inspection says I can do, and the power rule says, I just look at that composite function and I add 1 to the exponent. So I've got, and here's my 2 that just sits there. Then I add 1 to the exponent, so I'm going to go 1 plus half x, and if I add 1 to half, I'm going to get 3 over 2. And then I also need to divide by 3 over 2, which is the same as timesing by 2 over 3. And then add my constant of integration. So the reason why I do this is because when you differentiate this, you would use the chain rule. So you would find the derivative of this function, the 3 over 2 would come to the front. And because we don't have it here, you would need to get rid of it by timesing it by 2 over 3. Then I would subtract 1 from my exponent to get a half, and then I would differentiate my inner function, and that's where that half comes from if you go backwards. So, and then we just neaten this up. So we've got 4 over 3. We rewrite this with the roots, that's x over 2 or half x, that's really fine, to the power of 3, and we square root, that's the over 2 plus c. Okay, so I hope that explains what happens with these exponents, this idea of the 3 over 2, and also adding in where that 2 comes from.